Hello, students. I'm going to leave you to your do now and start with our objective. I better change the color, which will be to review the standard form, vertex form, and factored forms of a quadratic. We've got 2 lesson plate pages today. If you are in person, please show your work to me. I'll see you working. If you're a distance learner, upload your completed lesson into Teams. If you finish early, I have some activities below. I'll show you those. I also included last night's homework, so you can go over last night's homework. We don't have homework tonight, but tomorrow we're going to introduce a digital quadratic escape room challenge for you. So I'll leave you to your do now yourself so I can get right to the lesson, which is representing quadratic equations. We will represent them in vertex form, in standard form, or factored form. So we're going to complete each row of the chart with the given information. So we look at this graph, and we can see that, remember, the standard form of a quadratic is this. And then we have these transformations that we make to change the quadratic. So this quadratic has definitely been shifted from the y-axis to the right, to the left by 1. And it has also shifted down 1, 2, 3, 4, 5, 6, 7, 8, 9. So the equation of that quadratic is y equals, so we're using vertex form here, x, we've shifted left 1, so that would be plus 1 squared, and we've gone down 9, so minus 9. The standard form, so what we're going to do is factor this vertex form. So let's do that. Y equals x plus 1 times x plus 1 minus 9. So when we factor, we can use FOIL. So x times x is x squared plus x plus 1. 1 times 1 is 1. And we can combine this. So that would be y equals, and we still have our minus 9, x squared plus 2x minus, now plus 1 minus 9 is minus 8. So there's our standard form. So here's our vertex form, and here is our standard form of the quadratic. Now we're being asked to produce the factored form. So we need 2 numbers that add to 2 and multiply to negative 8. So those numbers would be 4 times 2, and the 4 would be positive, and the 2 would be negative. So the factored form would be y equals x plus 4x minus 2. And that's all there is to it. So let's change our color and let's go on to number 2. So it looks like the graph of y equals x squared. Remember, our parent graph is y equals x squared. It looks like it's been shifted to the right 1, 2, 3, 4, 5, 6, 7, okay, and down 1. So that would be y equals x minus 7, because we've shifted to the right, squared, and we've shifted down 1. So let's go ahead and convert that to standard form. So y equals x minus 7 times x minus 7. You'll get real good at foiling, minus 1, which would give us y equals x squared minus 7x minus 7x plus 49 minus that 1. So first we'll combine the middle. So we have x squared minus 14x, and then we'll combine the constants, which would be positive 48, and that is our final answer. Now let's factor this. We need 2 numbers that multiply to negative 14, I'm sorry, add to negative 14 and multiply to positive 48. So we're going to need two negative numbers, and negative 8 plus negative 6 equal negative 14, and they multiply to positive 48. So that would be y equals x minus 8, x minus 6, and our job is done. Okay, number 3. Let's look at the transformation. We have shifted. Here's our y-axis. And let's change our color, keep our work straight. And we've shifted 1, 2 to the right. So that would be y equals x minus 2. And we go to the right, it's minus 2. And we've shifted down 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's minus 9. So there's our vertex form. And our standard form, y equals, we'll convert this to standard form. We have x minus 2, x minus 2, minus 9, and let's FOIL, which would give us x squared minus 2x minus 2x plus 4. Negative 2 times negative 2 is 4, minus 9. So let's combine the negative 2x minus 2x first. So we have our x squared minus 4x, and then 4 minus 9 is negative 5. So there's our our standard form. To factor that, we need two numbers that add to negative 4 and multiply to negative 5. They will be a negative and a positive number. The negative number will have a larger absolute value. So that's going to have to be negative 5 and positive 1. Let me rewrite that so it's a little neater. So negative 5 and positive 1. So y equals x minus 5, x plus 1, and our work is done. You guys must be getting really good at the factoring. All right, now we're on the vertex form of, what we're doing here. Okay, this is a little different. This is kind of fun. They are giving us the vertex form in these next three, and we are going to write standard form and the factored form. So what do we know from this? Okay, we know that the vertex, the axis of symmetry, is going to be x equals negative 4. Okay, so we're going to have an axis of symmetry right here. And we also know that the vertex will be at okay. Okay, these are a little bit different. We're working on 4, 5, and 6. Here they're giving us the vertex form, and we need to graph it, then write it in standard form and write it in factored form. So let's get started. So let's take a look at the vertex form. We have y equals x plus 5 squared minus 4. So first we can tell the axis of symmetry is x equals negative 5. So let's find negative 5. 1, 2, 3, 4, 5. we can actually make a dotted line for our axis of symmetry, put arrows on it. Now let's find the vertex. And the vertex will be an ordered pair, x, y, which is going to be -5, -4. So we get the -5 because in the vertex form, we take the negative of that sign right there. We get the -4 from this value right here, the k value. So the vertex is -5, -4. Let's mark that. And it does not appear, it's not stretched, it's not compressed, so it's a pretty typical quadratic. We could find some ordered pairs, but let's just leave it at the vertex for now, okay? Now let's go to the standard form. Y equals x plus 5 times x plus 5 minus 4. So that would be y equals x squared plus 10x plus 25 minus 4, and I can combine those. Y equals x squared plus 10x plus 21. So that's our standard form. Now, to find where this quadratic will cross the x-axis, we're going to factor x squared plus 10x plus 21. We need two numbers that add to 10 and multiply to 21. They'll both be positive. So that would be 7 and 3. So the factored form, y equals x plus 7, x plus 3. And now we know that this is going to cross at -7 and -3. So let's see, -3 is right about here, -7, 3, 4, 5, 6, 7 is right about here, and we can draw. Because remember, when we set these to 0, we have x equals -7 and x equals -3. Okay? All right, so number 5, y equals -x minus 1 squared plus 1. So the axis of symmetry is going to be +1, x equals 1. And the vertex will be 1, 1. So write that down. Oops, put x instead of 1. So here's our vertex right here. So let's find this thing in standard form. So this would be y equals, oh, we also know it's going to face downward because of the negative sign in front of the x squared value. So when we figure this in standard form, it's going to be y equals the negative of x minus 1, x minus 1 plus 1. So it would be negative, in parentheses, x squared minus 2x plus 1. -1 times -1 is +1 plus 1. And when we combine like terms and distribute the negative sign through, and then we're going to add -1. This will be a -1, then a +1. So let me do all the steps for you. Negative x squared plus 2x. So this would be -1, and then we have that +1. So these will cancel themselves out. So y will equal negative x squared plus 2x. And when we factor this, we're just going to factor out the negative x. So y equals negative x minus 2. That would mean that this quadratic crosses the x-axis at 0 and at positive 2. Okay, because here x will equal 0 and x will equal 2. So there's our quadratic. We have a downward facing quadratic. We don't have any stretching or compressing. So draw it as best as you can. It's sometimes hard to draw these. Okay, let's look at number 6. So we're given y equals 2 times the quantity x plus 4 squared minus 8. So our axis of symmetry is 4. So that would be negative 4, because we take the negative of whatever that sign is. And our vertex is going to be negative 4, negative 8. And this is going to be stretched by a factor of 2. And we would have to substitute values to get that in much detail, but we're just going to work on these forms for now. So we have an axis of symmetry of negative 4. We have a vertex of negative 4, negative 8. And let's put this in standard form. So y equals 2 times x plus 4 minus 8. So 2 times, that would be x squared plus 8x plus 16 minus 8. And let's distribute and combine like terms. Y equals 2x squared plus 16x plus 32 minus 8, and then we'll combine at the end. Y equals 2x squared plus 16x plus 24. There's our standard form. So now we need two numbers that, well, this is actually, we can factor this first. So let's factor out the 2. We can factor out a 2. Y equals 2 times the quantity of x squared plus 8x plus 12, okay? Now we need two numbers that add to 8 and multiply to 12. They'll both be positive. So that would be 6 and 2. So y equals 2x plus 6, x plus 2. And that means that this quadratic will cross the x-axis at negative 6 and negative 2, right there and right there. And we can see already from the points that we've made that it has been stretched by this factor of 2. So it's going to be a kind of long, skinny quadratic. And you'll see when you connect your dots with a smooth line. And there it is. So that's just a review of what we've done so far with quadratics. And as I promised, the factoring really comes into play with this. So keep working on this. Do them over and over again. Ask me for graph paper. I've got plenty of it. This is great practice. And with practice, as always, you'll be great.